Good day, everyone!
So today, we will know the development of atomic theory. Are you ready?
Yes, we are ready!
Let's go! Did you know that the atomic theory has evolved over a long period of time? When scientific knowledge developed, scientists learn more, and their ideas about atomic model has changed. So in this presentation, you will know how atomic model has been modified when new evidence has been changed. So let's find out. So did you know him? Yes, he is a Greek philosopher, Aristotle, who developed a theory. Well, Aristotle did not believe that the matter is made of atoms, rather of four elements. We have fire, air, earth, and water. So his theory is subjective. Next is Democritus, which is next of Aristotle. In 400 BC, where evolution of atomic models started. So his first atomic model is a round sphere with no electrons, no protons, or even a neutrons. So his study of atomic model is a good start for other scientists to look further more.
John Dalton's later on December 3, 1803, John Dalton proposed his modern theory of the atom. He based it upon 5 factors, which includes that matter is invisible and indestructible. All atoms of an element are identical. Atoms of different elements have different weights and chemical properties. Also that atoms of different elements combine in simple whole numbers to form compounds. Finally, Dalton proposed that atoms cannot be created or destroyed. When a compound decomposes, the atoms are recovered and changed.
Next is Joseph John Thomson. In 1904, Thomson developed plumb padding model for raisin bread model. He discovered that each atom was a sphere filled with a positively charged fluid, known as the padding. Scattered in this fluid were negatively charged electrons. These were the plumb in the padding. He also suggested that positive fluid held the negatively charged electrons in an atom because of its electrical forces.
In the early part of the 20th century, Rutherford and his team, Hans, Geiger, and Ernest Marsden, carried out a series of experiments exploring the atom by shooting high-speed positively charged alpha particles at a thin piece of a gold foil. Their experiment shows that atom mass and its entire positive charged particles are confined in a small core called nucleus. The positively charged atomic model was also known as the Rutherford nuclear atom and the Rutherford planetary model.
Next is Niels Bohr. Bohr's model was similar to the model of the solar system. The electrons go around the nucleus like planets orbit the sun. The circular orbits or energy levels around the nucleus are called electric shells. These shells were at set distance from the nucleus. As the orbit becomes larger, the farther away they are from the nucleus. Note that he then numbered the electrons energy level. Each energy level holds a certain number or 2 electrons and 1 zoon. The electron energy level still apply the principle goes up from the level 1 to another level. He also pointed out the electrons can jump from a lower orbit to higher orbit by absorbing energy can be done in a form of heat, light, or electricity. The electrons lose energy when allowed to cool, giving the emission spectra for all different elements.
Erwin Schrödinger. In 1926, Erwin Schrödinger generated a mathematical model for the distribution of electrons in an atom. The solution to the Schrödinger equation led to the quantum numbers, which provide the address of the electrons in an atom. Erwin Schrödinger developed a powerful model of the atom in 1926. Schrödinger combined the equation for the behavior of waves with the de Broglie equation to generate a mathematical model for the distribution of electrons in an atom.
Study adapted. By analyzing the unknown radiation that was produced during this experiment, he discovered that the radiation was composed of particles with a neutral electrical charge known as a neutron. This discovery forced a revision of the cloud model, and scientists sometimes refer to the revised version as the CHEM30. And it made possibly the development of the atomic.
And that's all. We hope that you learned.
Thank you!